Let's take a look at the cell customer class we designed in the previous video and implement that in Java. We'll also create a driver class to test it out. If you haven't watched that previous video, it's really quick and you should probably take a look at that first. To begin, we'll right-click and create a new file. The file name is exactly the same as the class name with .java added onto the end. Depending on your folder structure, you might need a package statement up at the top, and that would be the same as the folder name. I'm going to go ahead and add a quick header block up at the top to identify the purpose of this class. Our first line of code is going to be this class header. It needs to be public, and again, our class name should be exactly the same as our file name. And of course, we're going to need a code block with a little space to work. We'll organize our code in the same way as our class diagram, so we'll declare our fields right up at the top. Each one should be private, and I'm just looking at the class diagram to see what I have designed. These are really just variable declarations with the keyword private to keep them encapsulated. Next up is our accessors or getters. As a new programmer, you should just get in the habit of making a getter for each field. And these just follow a basic pattern. It has to be public because the point is to give access. The method's return type will be the same as the field's data type. So this is for the name field, which is a string. And the identifier is the word get plus the field name, so get name. The parentheses will be empty. There are no parameters for getters. A basic getter has one line of code, return and the field. Now, I encourage the habit of using dot notation with all field references. I'm going to put this dot name. The this keyword refers to the current object. We don't have to put this dot. It'll still work if we just put name. The idea here is to get us used to that dot notation, which we'll need elsewhere. It's a good habit because we're going to see some situations where this dot is actually necessary. And also, it's just a good reminder that we're looking at a field rather than a regular local variable. Now, having said all that, there are plenty of coders who only use this dot when it's necessary, so this isn't a convention that's universal, and even I try and be a little realistic about it. Okay, so that's it for a getter. Since I have 4 fields, I'm going to have 4 getters, so I'll just use the same pattern to create the other 3. The next few methods on our class diagram are the set methods. Our setters will get much more interesting as we learn more, but for now they are also going to follow a simple pattern. A set method has to be public. For now, you should be making all your fields private and your methods public. As usual, we'll eventually see some exceptions, but this is how we implement encapsulation. We're hiding the fields and giving access to them through public methods. So public and then void. Setters don't return anything, their job is to set a value. The name is set plus the field. So in this case, set name. And in order to set a value for the field, we need to know what value to set. We'll need a parameter for that. The data type of the parameter matches the field. So for the name field, it's a string. And the parameter name can be anything, but I'm going to use CNAME, which is short for customer name. I'm intentionally not calling it just name because I don't want confusion with my field, which is also called name. Like a getter, a setter has one line of code. It's going to be an assignment statement. I'm just setting the value of this dot name to the parameter value, so CNAME. And just like our getters, this is just a pattern and we'll repeat it for phone number and monthly data. My last setter would be for remaining data. But before I do that, I'm going to stop and think. I'm not sure I really need a setter for that. I'm assuming we're using this method to initialize the data plan when the account is first created, so they won't have used any data yet. That means instead of writing a whole other set method, I'm just going to have this set method do both of those values. There's really nothing wrong with making a separate setter for the remaining data, but I wanted to point out that we don't always need a setter for each field. We're not really finished with this class just yet, but as a rule, I don't like to go a long time without testing my code, and that's especially true for beginners. So we're going to pause here and turn our attention to a driver class. This is another one of those topics that frustrates some students. This Sell Customer class is what I would call an object class, meaning its purpose is to get used to make objects. It's not a program in and of itself. We're going to have a completely separate file with the program that uses our class, and we're not going to just stick a main method in this file. That really seems to bug some people. The bigger potential frustration is that an object class like this should not have any user interface elements. No print statements, no scanner objects, no dialog boxes, nothing like that. That stuff is all part of the program itself, which goes in what we call a driver class. The analogy I like for this is the employees at a restaurant, where roles are very strictly defined and separated. In fact, they're separated so much that the food service industry has a pair of expressions for this: front of house and back of house. The front of house staff are the ones that interact with customers, like servers and bartenders, and the back of house staff are the ones who prepare the food. The front of house staff don't cook, and the back of house staff don't go talk to customers. And that's how we're going to treat our object classes and driver classes. The object class is the back of house, and it never interacts with the user. The driver class is the front of house that deals with the user and uses the object class as necessary. Despite how frustrating this can be for some people, it's a good habit to get into. It's going to make our code more modular and easier to maintain, and it's also going to make it easier to test our code. It's another case of a best practice that I enforce in my courses. So the bottom line is that we're going to create a separate class that will have a main method, and that's where we'll test our object class. That driver class will have any input and output that we need. Incidentally, we're not really making a program out of this. We're just focusing on the design of an object class. So my driver class isn't much of a program. Its job is just to test or demonstrate the object class. For that reason, you'll often hear me refer to the driver as a demo class or a test class, and I name those programs with that in mind. This is pretty common in my course, since we're focusing on the object-oriented design and not on creating full programs. This one isn't even going to have any user input. Okay, I'm going to get off my soapbox now and create a new file for our driver class. I'm going to call it sellcustomerdemo.java, and I'll start with a comment block to identify the purpose of the class, and of course we have our class header. This class needs to be public, and the name is going to be sellcustomerdemo, of course, to match the file name. When I'm working in this driver class, I'm back in that procedural programming mindset that we were using before we started talking about OOP. I'm going to create a main method, and if I want to make any other static methods, I can do that, just like before. This demo is going to be pretty simple though, so I'm just going to have a main method. I'll need to declare a variable of type sellCustomer, and I'll call it customer1. Now, this is no different than declaring any other variable, but now my object class is the data type. And just like our other variables, I need an assignment statement to make it useful. But the assignment statement will be different when I'm instantiating an object. I'm going to use the new keyword followed by the class name and then parentheses. This is a constructor call, and it's going to create a new object of the class type. We'll look at constructors in an upcoming video. Those two lines of code give me an instance of the sellCustomer class. I can run this program and make sure it's working, but it doesn't produce any output. I'll need a print statement to show what's going on. I'll start with a print statement that just outputs the object variable, and we'll run that. I did get some output, but it's not very useful. The output is the name of the class, followed by an @ symbol and a hexadecimal number. We've asked it to output the whole object, and this is what Java does by default. The number is the memory address of the object, which is interesting but not really very helpful. What I really want to do is output some of the fields in the class. So let's start with the remaining data. It doesn't let me refer directly to remaining data because we've encapsulated that like we're supposed to. To get that, I'll need to use the getRemainingData method. Let's run that and see what we get. Okay, I got a 0, which is what I expected. I haven't set any values for the fields, so they're all at their default values, which is 0 for a numeric field. Let's do the same thing for the customer's name using the getName method. It says null. Remember that the data type string is capitalized because it's a class. It turns out that whenever we're using a string, we're instantiating an object. Since we use strings so much, the Java designers made it so that we can use strings pretty much the same way as numbers, but it really is an object. And the default value of an object is null. So that's what we're seeing here. To get values into those fields, we need to use our setters. Make sure we're doing this above the print line statements. And now we'll use that dot notation to call customer1.setName. As an argument, I'll pass in a name. Running it now should get rid of that null. Okay, it looks like my setName and getName methods both work. The last confirmation I'll need is that the fields are actually scoped to the object. So I'll need to come back up here and make another cell customer object, which I'll call customer2. And we want to make sure that editing one doesn't edit the other. This time, I'll combine the declaration and assignment into one line, just like we often do with other variables. I'll call the setName method on customer2 and I'll pass in a different name. And now I'll add a print line to show that name as well. Okay, now I've really confirmed that the name field and the methods that go with it are working correctly. So I'll need to do the same with the other fields. I'll set the values for phone number and monthly data. Remember that setMonthlyValue method also sets the remaining data field, so I don't need to do that separately. And now I'll just output all three of those. Let's run this and make sure it's working. And it is. I've got all my fields set and I'm able to get them back out. So I'm confident that my object class is working as designed and the objects aren't interfering with one another. Now we can go back over to our object class and finish up the remaining methods. These last few methods are what I would call mutators. They don't just directly set a value like our setters do, but they do end up changing the object's data, and mutate means change. First up is a method we can call when the customer uses some of their cell phone data. It's public, so we can actually use it, and it's void because I'm not asking for any information back. We're just going to reduce the amount of data the customer has left. We could write a method that reduces the value of the field and then also returns how much is left after we make that change, for example. And that might actually be a really good way to write this, but for the sake of our beginners, I'm trying to keep things really clear by just having a void return type on this method. Our parameter is just the amount of data that the customer has used. The body of this one is pretty straightforward. I'm just going to subtract the amount from the remaining data, and that's it. Let's jump over to our driver class and test this method. I'm going to add a call to use data for customer 1, and I'll pass in a number. And then I need to output the remaining data again to see if it's changed. I want to output both before and after. I'll run that and see if it's working. Okay, at this point we're almost finished. The last two methods are really similar to each other. The idea is that there are two ways for the customer to increase their data. They can buy more, which is the add data method, or they can have their plan reset at the beginning of the month, which is the reset data method. Okay, let's do add data. This is the same as use data, but it adds instead of subtracts. And since that really was a pretty basic addition, I'm just going to go ahead and do the other method before we test. Reset data doesn't really add on to the remaining data, it just sets it to the monthly data amount. So this one is public void, no parameters, since the amount it gets topped up to is the monthly data that they get with their plan. So the body just sets remaining data to monthly data. And now let's go test both of those. That really is it for this class. We've got all of our fields, getters, and setters, and our mutator methods. We've tested all of our methods in our driver class, which we've kept separate. and we're confident that our class is working the way that we've designed it. So that really wraps up this project. Like I said, it's not really much of a program and doesn't even have user input, which is often what I do on my course assignments. We still have a few important topics to look at with basic classes and objects, but this gets us started with the basics of object-oriented programming.